Okay, in this next example, find x. Assume that segments that appear to be tangent are tangent. So this is just more applications of the fact that we know the radius, so you want to locate those radii, are perpendicular to the tangent. So here's the line that touches the circle but doesn't go into the circle, so that's your 90-degree angle right there. So question is, how could we solve for x? Well, we have a lovely right triangle, and we can do the Pythagorean theorem to find the hypotenuse. So we're going to do 10 squared plus 24 squared equals c squared. You might notice that this is a multiple of a triple. This is a 5, 12, 24. 5, 12, 13. So if you take 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26, so we know C will come out to be 26. Okay, so pause the video. You tried. This is another triple, just saying. Okay, so again, your radius meets your tangent line right here. The tangent line is that x that's touching the circle at point F. Your radius is the 8. So you have a lovely right triangle. Make sure that you put 17 in the C spot in a squared plus b squared equals c squared. Otherwise, it won't come out right. This triple is an 8, 15, 17. So hopefully you got x to be 15. All right, and then the next theorem just says the same thing in reverse. It's the converse. It's the backwards version of the original theorem we looked at today. If a line in the plane of a circle is perpendicular to the radius at its endpoint on the circle, that line is not just any old line. That line is tangent to the circle. So this whole perpendicular thing we've been talking about, it only happens when this line is tangent. It doesn't happen when the line goes through the circle, at least not all the time, but it will always happen when the line is tangent to the circle. So we're going to play is the line tangent, determine whether each segment is tangent to the given circle. So if this is tangent, then that means that this is a 90-degree angle. How do we know if that's a 90-degree angle? Well, we learned back when we studied right triangles, the Pythagorean theorem only works with right triangles. So the question is, does a squared plus b squared equal c squared? That's the question. So does 9 squared plus 40 squared equal 41 squared? That's the question. So we're going to put that in our calculator. So we have 81 plus 1600. Does that equal 1681? I would say yes. Yes, it does equal. So because a squared plus b squared does equal yes, HI, that segment is tangent to the circle. It's touching the circle at point H. Okay, so let's make part B a you try. So pause the video and see if you can decide if 4 squared plus 12 squared, does that equal 13 squared? So make sure that you're putting 13 in the C spot because it's the biggest number. The biggest number always has to go in the C spot. And so we have 16 plus 144. Does that equal 169? Well, this comes out to be 160, so that would be no. So line AB is not tangent to the circle, to circle C. All right, and there's one more you try here. I think you guys have the hang of this. I don't think we even need to do that you try.